Last week we learned the sum and difference rule, which said if you had a function like this, you can just take the derivative of each one separately, and that's the derivative of the whole thing. Forgot the little notation. Pew! There we go. Straightforward. So now we have two things multiplied. And if we go the same way and think the same way that we would think for adding and subtracting, just take the derivatives separately and add them, we might think here, well, let's just take the derivatives of both things separately and add them, and multiply them, because we're multiplying here. And that's exactly what Leibniz's first guess was. Let's just take the derivative of each one and multiply them, and then he found out that that was wrong. Because if you take a simple example, which is x times x to the 4, what's the derivative of x? 1. What's the derivative of x to the 4? 4x cubed. Does that equal 5x to the 4? No. So we can see in a simple example why we can't just take the derivative of each one separately and then make it work out to be that. So after a little bit of work, this is what he found. Whew. Does that look simple?
That's cool.
It does look cool. What does it mean? Well, it means if you have two functions, and we're going to color code things here, because if we color code things, it's going to be so much easier. So I'm going to color code one in green and one in blue. And what it means is if you are trying to find the derivative of this, you keep the green one the same, the first one the same, and multiply by the derivative of the second one. And then you keep the second one the same and multiply by the derivative of the first one and add them together. This is one notation. Sorry, this is bad wording right here because, oh, that's not good. And there we go. You don't get a formula sheet. Did I take it off of yours?
No. I was happy for a moment.
You're happy for a moment? Sorry. So in Leibniz notation, again, we'll color code this. We've got our first function u multiplied by our second function v. Again, we keep the first one the same, multiply it by the derivative of the second one, then keep the second one the same, and multiply by the derivative of the first one. Now, when you take this course in university, you're going to see a proof of this. You're going to see why this happens. What we're going to do right now is we're going to take it as a rule that we're going to be able to use and see how it works from there. So if y equals x squared times 2x minus 1, according to the product rule, again, we'll take out our highlighter. I'll use the same color code screen. There's 1, there's 2. Can you see that the green function is multiplied by the blue function? So according to our formula, we would keep the first one the same, multiply by the derivative of the second one, then keep the second one the same and multiply by the derivative of the first one. So with this in mind, our derivative is going to be keep the first one the same. What's the derivative of the second one? 2. Plus keep the second one the same. And what's the derivative of our first one? 2x squared. Pulling out our highlighter again just to see where things... Thank you. Whew. Those are the ones that stayed the same. Touch that up. It's just 2x. Perfect. Now that is using our product rule. Can you see in this one that if you multiplied it out, distributed that x squared, you would get 2x cubed minus x squared. And then you could do this derivative all at once because it's just adding and subtracting. Your derivative would be 6x squared minus 2x. In this case, I like the black better. It looks like it took just about as much time. And my answer is simplified. But that's not always going to be the case. It's not always going to be the case that you can easily multiply something out to do it in a simpler way.
Can you not simplify the green one any further? Like
Sure. And when you go to check your answers in your textbook on the answer key, they will always have things factored or simplified. So one of the things I want you to do is once you get your answer, I want you to check the answer in the back of the book and see if you can manipulate your equation to get it to look like that. So if you have this in green and the answer key said it in black, could you manipulate that? And this one's not hard because if I multiply this out, right, I'm going to get 4x squared plus 2x squared. That's going to give me 6x squared. And negative 1 times 2x is going to give me the negative 2x. So try this one. Try it in both ways. Try multiplying it out and try using the product rule and simplifying it. So you can check if you use the product rule, the answer there is in blue, and that's not simplified. If you expanded it first and then just used your regular power rule, and one more for you to try. You want to go back? So unsimplified, this is what it would look like. And sometimes what I do for the product rule is just remember it like this. Keep one of them the same. Because you're adding, right? The order doesn't matter. Keep one of them the same. Doesn't matter which one you do first. Keep one of them the same, derivative of the second one. Then keep the other one the same, and then derivative of the first one. So you're always keeping one the same and derivative of the other one and adding those up in the end. And it doesn't matter which order you do that because adding doesn't matter the order. So there is some exercises to do at the bottom there to practice your product rule. Or if you would like a challenge to see if you can do a product rule within a product rule, I'll give you this one. There you go. If you want to have some fun, try that one. Yeah, I can go back.